All right, let's talk about a technological shift that's so big, it's on par with the invention of the computer itself. I'm talking about the quantum revolution. It's a world of mind-bending physics that sounds like science fiction, but it's happening right now. And India is placing a massive bet to be at the front of the pack. So let's get into it.
First things first, we got to understand the heart of it all, the qubit. Now your phone, your laptop, they all run on bits. Think of a bit like a simple light switch. It's either on or off, a 1 or a 0. That's it. But a qubit? Well, this is where things get wild. Thanks to a bizarre quantum trick called superposition, a qubit can be a 0, a 1, or, somehow, both at the exact same time. It's this ability to exist in multiple states at once that gives quantum computers their absolutely unbelievable power.
And this isn't some far-off fantasy anymore. As this quote from your story puts it so well, the rules of the tech game are literally being rewritten as we speak. And this is really where our story begins, because India isn't just sitting back and watching. No way. It's jumping right to the forefront with a really bold national strategy.
So let's start with the big picture. This is India's strategic plan to build a quantum-powered future, and it's called the National Quantum Mission. You can think of it as the government's official blueprint for becoming a global powerhouse in the quantum space.
And what's really stunning here is just how serious they are about it. Look at this number. That's over 6,000 crore rupees. This is not just some small research grant. This is a massive statement of intent. India is investing serious capital to build an entire quantum ecosystem right from the ground up.
The official name for this whole effort is the National Quantum Mission, or NQM for short. And the goal is pretty straightforward, to supercharge both the scientific research and the industrial side of things over a pretty ambitious 8-year timeline. The whole idea is to make sure those amazing breakthroughs in the lab turn into real-world products and applications as fast as possible.
And when you look at the goals, you see just how ambitious this mission is. I mean, we're talking about building quantum computers with up to 1,000 qubits, developing unhackable satellite-based communication networks that can span the entire country, creating sensors so precise they sound like something out of a movie, and even inventing entirely new materials that are needed to make all this tech actually work.
So, how do you actually get a mission this huge off the ground? Well, the plan is to use these 4 specialized thematic hubs. They've been set up at India's absolute top-tier scientific institutions. Think IISc Bengaluru and the IITs. And each hub is going to focus on a specific piece of the quantum puzzle. One might tackle computing, another communication, and so on.
But look, a government mission is only one half of the story. The real action, the real excitement, is with the innovators who are actually building this stuff. So let's shift gears and dive into India's absolutely exploding quantum startup scene.
Get ready for this. In just the last 2 years, over 40 new quantum startups have launched in India. 40! That's an incredible burst of innovation. It proves that this ecosystem isn't just a top-down government plan. It's a real, vibrant, commercial reality that's bubbling up from the ground.
So let's meet a couple of the key players. On one hand, you've got a company like QNU Labs. You can think of them as the guardians of quantum security. They're using quantum physics to create encryption that is, in theory, mathematically impossible to break. Then you have companies like BosonQ, and they're on the software side, building tools to harness quantum power for really complex simulations. Things like designing revolutionary new materials or discovering life-saving drugs.
And this is where things get really fascinating. You have companies like QPI AI that are working at the crossroads of 2 of the most powerful technologies on the entire planet, artificial intelligence and quantum computing. They're actually building platforms to merge the 2, which could open the door to a next generation of AI that could solve problems we previously thought were just impossible.
Okay, so we've talked about the big strategy, and we've talked about the startups. But what does this technology actually look like in the real world? It can feel a bit abstract, right? So let's look at a groundbreaking experiment that makes all this theory really tangible.
The challenge was laid down by ISRO, India's space agency, and the goal was simple but incredibly difficult. Send a perfectly secure communication signal using quantum principles between 2 buildings, 300 meters apart, right there on their campus. This was a real-world test of a technology that could one day secure everything from satellites to critical defense communications.
So, how did they pull it off? They used a technique called quantum key distribution, or QKD. Here's the simple version. A sender, who we'll call Alice, sends a stream of tiny light particles, photons, to a receiver, Bob. Now here's the magic part. The laws of quantum mechanics say that if an eavesdropper tries to intercept and look at those photons, the very act of observing them changes their state. It leaves a footprint. Alice and Bob can spot those changes instantly. So if there are no errors, they know for a fact that their key is secure and physically, fundamentally uncrackable.
And this wasn't just a computer simulation. This is the real hardware they used. On the left, you've got Alice, the transmitter that's sending out the encoded photons. And on the right is Bob, the complex receiver module that's catching them. This is what quantum communication actually looks like today. Now, to make this work over any kind of distance, you need timing that is absolutely perfect. We're talking down to the nanosecond. And what's so clever here is that the ISRO team used India's own navigation system, Navik, which is kind of like their version of GPS, to synchronize the clocks for both the sender and the receiver. It's just a fantastic example of using one advanced national technology to enable another one. And the result? A huge success. The team successfully created a secure quantum key and then used it to have an unconditionally secure video call between the two buildings. This was a real-world demonstration that this future of unbreakable communication is a lot closer than many of us think. So, an amazing experiment, a huge national mission, and a booming startup scene. But let's zoom back out. Why does all of this really matter for the future? What's the big deal? The truth is, the impact is going to be felt pretty much everywhere. In healthcare, quantum computers could simulate molecules and help us discover new life-saving drugs in record time. In finance, they could create incredibly powerful models to predict the markets. And for defense and telecommunications, like we've seen, it means a whole new era of unhackable, secure communication, protecting everything from military secrets to your personal data.
Which brings us to a final, really critical question. In a world that's more digital, more connected, and, let's be honest, more vulnerable than ever before, is this quantum revolution, with its promise of unbreakable security and unimaginable computing power, the actual key to securing our future? It's a fascinating thing to think about.